Good afternoon, class. Today we're going to be looking at the Milestone 3 assignment, and specifically we're going to zero in on the requirement for creating an abstract class, and in this case for the drink. So if we zoom down to those specific details, we're going to be creating an abstract class named drink in a file named drink.cs, and it needs to have the following properties, at least these properties: a getter of type size, a getter of type double that is called price, a getter of type uint which is called calories, and a getter of type list string that will be special instructions. And then alongside that, all the drinks are going to need to be refactored to use this base class. So the right place to do this is we would want to probably create this in our drinks namespace. We're going to add a new class, and I'm going to call this one drink in line with the requirements. So we will create, this is public and abstract. An abstract class means that we cannot construct an instance of this drink class. And once we've declared it abstract, its really only purpose is to serve as a base class. And we want to go ahead and do all those requirements we said. So we need to have a size, which is coming from bleakwindbuffet data.enums. And let's go ahead and we need to declare this as either abstract or virtual. And either one is perfectly fine. If we declare it virtual, we are going to make sure that we set it needs to be a property as well. So this sets us up. If it was abstract, we'd have to re-implement this in our other drink classes, and if it's virtual, we can just declare it here, and then we have the option of overriding it in our other drink classes. In this case, virtual makes a lot of sense because all of the drinks are going to use the same kind of size property. Then we can do a public abstract, and this property is going to be price, which is going to be a double. And public abstract uint calories. And the reason I am doing these as abstract where I did size as virtual is for these I am always going to be overriding these. And the other thing is these can be read-only. If we read the directions, we say these just need getter, and getter, so these are basically read-only. So we don't necessarily need to provide a body here because we are going to basically have to say what the price is of each individual kind of drink anyway. So we know that we're going to have to overwrite that. So I might as well just make it abstract and not have a base value in it. Whereas the size, I can get away with not overwriting that. So it might behoove me to actually use a virtual there. And let's go ahead and do the last, the public abstract list string special instructions. And again, this should only need a getter, so I'll go ahead and specify those. Now, anytime we create a new class, we need to go ahead and document a base class representing common properties of drinks. And we'll go ahead and set give a comment for our size, the size of the drink, and then the price of the drink, and we might give this a value in US dollars, and the calories. And finally, special instructions to prepare the drink. All right, so that is now an abstract base class, and notice we didn't really supply any bodies. Now this is an auto property because it is virtual. We technically are giving it a body. It's just that the compiler is creating it for us. So we could have gone ahead and declared a private backing variable and use that in there, and that would actually count for that. Now if we jump to, say, our AretinoAppleJuice, now we want to say that this is going to inherit from that base class. So we'll go ahead and add a drink. So as soon as we add this, we notice that it now starts telling us we're not inheriting abstract member, or not implementing inherited abstract member special instructions, and we are not implementing abstract member drink price get and drink calories get. Now if we go in here and we actually look, we do have, for example, we're declaring the size, and notice here it is telling us that we are hiding the inherited member drink.size. So drink defines a size for us, and now we're defining a second size which is overriding that. So we would either want to have an override keyword in front of this to say that this is going to be the size for the apple juice instead of the one out of the base class, but because that is virtual, we can go ahead and use the one out of the base class, and we can just delete that. Now for the price, we actually want this functionality, which is very specific to the AretinoAppleJuice, so we're going to have to say that this is an override. So this overrides that abstract price that we declared here in drink. So we are now implementing this price. And if I come back to the AretinoAppleJuice and look at the errors, notice it's no longer telling us that we don't implement that abstract member. And we're going to do the same thing for calories, to say that this is going to be implementing the calories that this abstract base class is promising that we'll implement. So again, an abstract method declaration is basically a promise that everybody who inherits from this class is going to actually implement that particular property or that particular method. All right, and we need to do the same thing for our list of special instructions. And anything else that we are overriding now, and we've already overridden the toString. We did this last milestone because that toString is actually defined an object. An object is the base object of all objects, or the base class of all objects. So that would also be an override. And now, if we take a look at this, we have no more complaints. We've met our requirement that our drink base class and all drinks need to be refactored to derive from that. We have refactored the Aretino so that it does derive from that. Now we'd also want to go in and modify our tests to basically show that we can treat this Aretino as though it were a drink, as well as treating it as an AretinoAppleJuice. So this will be another fact, and we'll use something along the lines of public void should be castable to drink. Or we could even say should be a drink. Yeah, that'll work. And if we look at our assertions to test if something is castable, we can ask the question, is assignable from. And this is a templated method, so we put what we're assigning it from into the angle brackets here, and we want to use that drink, and then we have to pass in the object that we're testing. So just like our other test, we're going to actually declare an AretinoAppleJuice. AJ equals new AretinoAppleJuice, and we'll put this in here. This is a very easy way to say is this something we can cast into a drink, or does this actually implement, or in this case inherit from that drink class. So if I go to my test explorer and find new test I just added, in the drink test, AretinoAppleJuice should be a drink. I run that one, And notice that that test passes. It's also a good idea after we make changes like we did to the drink class to actually rerun all of our tests, that idea of regression testing. Just make sure that they all continue to pass. And it looks like we're in good shape there, so all our tests are working, and as long as our tests did a good job of covering all of our functionality, we should be in good shape. And that's basically it for adding that base class. We'll have to go ahead and add that to all of our other drinks. We'll do the same thing for the entrees. We'll do the same thing for the sides, only with different base classes. And then for each of those, we also need to make sure that they now implement the order item interface. And we'll go ahead and leave it at that.